Good morning. In the beginning, I would like to say that I cooperate in these topics for many years with Japanese colleagues, with Professor Junichi Ueda, Professor Kensuke Miyamoto from Osaka Prefecture University, and from Professor Hiroshi Okubo from Kyushu University. Also, so my colleagues from Poland cooperate in this field. So I am very glad that I have a chance to present here my lecture concerning our joint data, and I am very glad as we invited here to present our joint results. The title of my topic is hormonal control of shoot growth in tulips and other bulbous ornamental plants. I started this kind of work from 1970 after my PhD. So it is a long work. I would like to present a piece of this kind of work. In tulips, in the growth and development of tulips, we can distinguish three different phases. One is phase initiation and deformation of new sprouts with flower buds at high temperature. So after duck up of the bulbs on the end of June, the bulbs are consistent only with the basal plate and the scales, no flower buds. And during the storage of the kind bulbs from June until the end of September, flower bud is formed inside of the tulips bulbs. And in September, the flower buds is formed. Next one, it is internal preparation for stem elongation at low temperature. After flower bud formation, tulip bulbs needs low temperature treatment, about from 12 to 16 weeks at 5 degrees centigrade. It is necessary for normal growth upper part, it means shoots. So in natural conditions, the low temperature treatment takes place in the winter, but in the laboratory condition, we can keep as unrooted tulip bulbs at 5 degrees centigrade for 3 months. And after, on the spring, or after 3 months in artificial cooling in the cold room, we can tulip planted, and on the spring, we have high temperature, and rapid elongation of the sprouts take place. Tulip bulbs are ready for cooling if the pistils is fully differentiated. Here is the pistils, and we see stigma, and you can see pistil stigma, yes, is formed, and stamen is here. So growers, they know if they cut the tulip bulbs, if the stage is ready, the tulip bulbs for cold treatment. So many attention is paid in literature concerning the role of endogenous hormones during dormancy release, and the growth of the tulips. So generally speaking, at high temperature, it takes place flower formations, and after flower formation, tulips are dormant. So it means after planting, no more growth of the tulips, because they were rooted but no growth. So then a low temperature treatment is necessary for the growth on the spring. And of course, we have different kind of hormones in the plant kingdom, the same of course in the tulips. Here we have these hormones like abscisic acid, gibberellins, cytokinin, auxin, ethylene, polyamines, jasmonate. So during different phases of growth development of plants, including tulips, we have different kind of balance between different hormones. One is decrease, another decrease, and finally decide about different stages of the growth and development. For example, if tulips are dormant before low temperature treatment, the level of abscisic acid it is high. After cooling is decreased. High level of in dormant bound gibberellins then decrease after cooling. Low level of gibberellins in dormant and increase after cooling. The same cytokinin, auxin is increased after cooling. We don't know so much about the role of ethylene, polyamines, and jasmonate in the growth and development tulips. Of course, jasmonate, our joint work, we found that jasmonate occurs in the tulips as endogenous hormones. So here's this example. Here you can see uncooled dormant tulip bulbs. After planting in the October, the tulip bulbs are rooted and no growth. In that case, tulip bulbs were kept until January at 70 degrees centigrade. In that case, tulip bulbs were kept during 3 months until January at 5 degrees centigrade after flower formation. So, end of January, they are planted. You can see here, dormant tulip bulbs, rooted, but no growth of the upper part, no shoots. After planting of the cool tulip bulbs, we have normal shoots growth, stem elongation take place, leaves, and the flower buds. So low temperature treatment is necessary for the tulip to shoot the growth on the spring. So we are interested what it is role. I would like to say what it is role of auxin in this tulip stem growth. So here, we have made the experiment that in January we planted cool tulip bulbs, fully cool tulip bulbs, and when the length of the shoots was about 7 centimeters, all leaves and flower buds were removed, were cut. So of course, after cutting of the leaves and flower buds, no more growth of the stems. Here, we observed normal growth of the intact tulip bulbs. You can, the flower will be flowering during next 2-3 days, normal growth. But if this kind stage, after removal of the leaves, flower buds, we applied auxin on the top of the stems. So we have observed normal elongation of the stems. Here, no growth. Here, after application, additional application, of course, one auxin, indole acetic acid, IAA, at concentration 0.1% in nanopaste. During 7-8 days, we have normal growth of the stems. So, carbohydrates, storage materials contained in the tulip bulbs, each mostly polysaccharides, fructosans, and different degree polymerization, and starch, as degraded, and sucrose is formed as transported sugars, and the transported sugars, sucrose, is used to debuild all the stems. So it is a nice model for study degradation of the polysaccharides and use for the growth of the new tissue. Because here we have no leaves, no photosynthesis, just stems. So it is really for us was surprise when treated auxin. So induction of the growth take place.